Hello everybody, this is the notes for Advanced Geometry 3.3. What we've talked about in section 2 was having parallel lines cut by a transversal. It gave you those special angles, the properties of them. Corresponding angles are congruent, alternate interior angles congruent, consecutive interior angles, supplementary, that kind of thing. But we were going in the direction of if we had parallel lines cut by a transversal, then we had these angle properties. This section, we're going to go the other direction. We're going to use those angles to help us prove that the lines are parallel. And so that's what it says here in the objectives. We're using the idea of a converse statement. All right, so you don't really have to copy this part down, but definitely read through it, pay attention. Remember the converse, you are switching your hypothesis and conclusion. And so, like I mentioned, for this first one here in orange, what we talked about in section 2, 3.2, is that if you have parallel lines cut by a transversal, then corresponding alternate interior angles, whatever, those special pairs, if you had the parallel lines cut by a transversal, then those angles were, whether they were congruent, maybe they were supplementary, whatever the property was for those, that was the statements that we had. You make the converse of that statement, and that's what you have here in green. If two lines are cut by a transversal so that corresponding angles, alternate exterior angles, whatever, if two lines are cut by a transversal so that those special pairs of angles are congruent, supplementary, whatever the property was for those kinds of angles, if you have that property, then the two lines are going to be parallel. So it's just a converse. We're going to use those angles and those properties to say, if I have these angles, if I have corresponding angles congruent, then those lines have to be parallel. Go ahead, hit pause, copy these things down. Again, with these, names are important. We're going to be doing some proofs with them. When you make a statement that lines are parallel, you need these names. Okay, so you copied all these things down. Again, the whole idea here is this. Let's just look at the second one here for alternate interior angles. The idea is if you have angle 5 congruent to angle 4, 5 and 4 being in the alternate interior angle position, if those angles are congruent, then line J is parallel to line K. That's what these statements are saying. So, here's a couple of problems that you'll see in the homework. I forgot to put the directions on there, but the question says, what value of X makes line M parallel to line N? All right, so looking at this first picture here on the left, you have these two angles, the 4x minus 28 and the 100-degree angle. They are corresponding, or at least they're in corresponding position. We don't know these lines are parallel. That's what we're trying to do. We're trying to get what x value makes these lines parallel. So they are in corresponding angle positions. If the lines were parallel, these two angles would be equal. We don't know they're parallel, but we're trying to say, all right, I'm going to make these two angles equal so that I do have congruent corresponding angles. So we're just solving for x. Divide by 4, that gives you a 30, x equals 32. So here is the x value that makes these corresponding angles congruent, which if you have corresponding angles congruent, line M here would be parallel to line N. Okay, that's the idea. For this example, it's question number 12. These two angles, they are in alternate interior angle positions. So the thought process, if those lines, M and N, were parallel, cut by this transversal, if the lines were parallel, these two alternate interior angles would be congruent. Okay, so we don't know they're parallel, but we're going to make these alternate interior angles congruent, which is going to force the lines to be parallel. So, solving for x, I'm going to add 95 to both sides. I'm going to subtract a 1x from both sides. There's the x value that makes line M parallel to line N. All right, so I mentioned earlier, we're going to be doing proofs with some of this stuff. So let's take a look at this one. Go ahead, hit pause, try this on your own, see if you can make all the connections to prove that line P is parallel to line R. Okay, I hope you got it. So, always start with the given information. Line G is parallel to line H. You are also told angle 1 is congruent to angle 2. So, in a proof, statement 1 is always the given information. G parallel to H, angle 1 congruent to angle 2. We know that is true because it's given to us. The next statements in proofs are always, what else do you know from the given information? So, we don't know much else from angle 1 being congruent to angle 2, but we do know that line G and H are parallel. So, lines G and H are parallel. If we look at line P as a transversal, angle 1 and 3 are corresponding angles. So we can say that angle 1 is congruent to angle 3 because of the corresponding angles. This is not a theorem, this one was the postulate. Okay. Lines G and H are parallel to each other. Line P is the transversal. 1 and 3 are corresponding angles, so they are equal to each other. Now, we're trying to prove these two lines are parallel to each other. In order to prove lines parallel to each other, you need to show one of these pairs of angles are congruent or supplementary. You need to show the property for these pairs of angles are true, which makes the lines parallel. So, if we're trying to prove line P is going to be parallel to line R, we need to say that 2 and 3 are congruent. They're corresponding angles. If the corresponding angles are congruent, then the lines are parallel. Okay, so looking at the statements that we have, in the given, we got angle 1 congruent to angle 2. We just said angle 1 is congruent to angle 3. That leads us to the next statement that angle 2 is congruent to angle 3 because of, and say it all together, transitive, good. All right, so angle 2 is congruent to angle 3. Once we got one of those special pairs of angles to have that given property, you got your lines are parallel. So we can just make the statement, line P parallel to line R, and our reasoning is 2 and 3 were the corresponding angles. So it is the corresponding angles, postulate, converse. That's how we should be writing it out. That's the proper way to write it out. Sometimes what I'll do, just out of force of habit and not wanting to write all of that, I'll write it like this. Corresponding, and I'll usually use this angle symbol, corresponding angles congruent implies parallel lines. It's a lot more symbols, but it's saying the same thing. If you have corresponding angles congruent, remember this is the if-then statement, this little double equal sign arrow thing. If the corresponding angles are congruent, that implies that the lines are going to be parallel. This is the proper way to make that statement. I'm pretty cool with that one. And that is it for this section and this proof. I'll see you in class tomorrow.